Right, so pause the function again. Pause K again earlier. Or what we got for K earlier. One on 7.5. So what was that? 2 on 15. Excuse. So it was 2 on 15 of 4 minus x, and you have to multiply all of this by x between 0 and 3. Right? That's the way you find e of x, right? E of x squared, well, you square the whole thing. Dot dx. So pull out the 2 on 15 and multiply with everything. So you'll get 4x minus x squared dot dx. Right, then do your integration. Right, do your integration quickly. Right, that'll give you 4x squared on 2 minus x squared on 3. Then you plug in the 3 and you plug in the 0. Right, so that'll be 2 by 3 squared plus 3 cubed over 3. How much is that? $1.2. So 1.2 is the value for e of x, right? This is just a homework I'm going through, right? So e of x is 1.2. Now they want you to state fully the cumulative function. So when they say fully, they want everything between 0 and between less than 0, between 0 and 3, and more than 3. Do that fast. Right, f of t is the integral between 0 and t of 2 and 15 of 4 minus x dot tx. So that will be 2 and 15, plugging in t one time, right? So that's 4t minus t squared on 2. Okay, that's what your that's what your differential, that's what your integral will look like. Yeah, I will. Right, so that'll be 4t by that, and you can multiply it out. But when they say they want the full description, remember, when x is less than 0, the answer, the cumulative is 0. When x is between 0 and 3, it will be that function there, right? It will be this function here, right? 2 and 15 by 4t minus t squared on 2. Right? And then when it's more than 3, it'll be, well, 3 not included. When it's more than 3, the answer is 1. So when they say describe fully, that's what they want, right? Right? Copy down. We just doing the homework here, Jude. So just correct it, pass. All right. And the last part, what they asked for in the last part, find the probability between minus 1.5 and 2. Right? So you could integrate again, or we could just plug in, oh, by the way, this should be x, and I'll see I wrote back t. This should be x. All we have to do is plug in 1.5 here, and then plug in 2 there, and then subtract the answers. That's all we have to do for this last part. Okay? So those are the things that we did last day. Today, now, we want to take a look at the normal distribution, right? We did it already in Unit 1, but I just want to just make sure you remember how to read it, right? All right. So if you look here, we have some little notes here on the Unit 1 for the normal distribution, right? The normal distribution is shaped like that. It's a nice continuous distribution, as you can see here, right? And it's made up of a nice symmetric shape, right? So the normal distribution, the two parameters for the normal will be the mean and the variance. Okay? In order for you now to, because you could have so many different normal distributions, in order for us to actually read off a value, we have to standardize it. So we have to convert the normal distribution to a mean of 0 and a variance of 1, right? That's what I mean by standardize. And once the mean is 0 and the variance is 1, what you have is the normal distribution, right? It's called standardization, right? So if you have to read off now, go to your tables, right? Go to your tables. Anybody doesn't have a table? Anybody can just share back the table in the beginning of the group? In the beginning of the group, just share back the table now so everybody can have it. Anybody can just share back this in the group? All right, nice. All right, so open it up and you want to find the probability of Z is less than 0.45. You go to your table and you read off 0.45, which gives you all of this area here. Right, that area should be bigger than 1, of course, and you end up with a probability of 0.635. So go to your table, look for 0.3 on the left-hand column, and then look on top for 4, and then look across to 5. And you should see that the corresponding reading is 0.6350. All right. Remember, if it's more than, you have to read off 1 minus the less than value. So go to your table, read off 0.345, and then minus it from 1. And you'll get this value here. Okay? So once it's more than, you go and read off that, right? So that's your more than, right? You have your more than, your less than, you have all the other rules, right? I don't know where all the, hold on, if I can find the other rules for you. Let's run over fast. This is just to make sure you remember how to read off the normal distribution, right? Oh no, I just finding out this one, right? I'm finding the next one. All right, but if you check back in note, you will see all the rules for the normal, right? I'm gonna just check one more place. Give me 1 second again. Nah, I ain't seen it. All right, so you kind of have an idea of what the normal distribution is. Let's see how the normal distribution comes into play here, right? So in order for us to use it here, here's what has happened, right? If you remember all those distributions, the binomial, Poisson, and so on, right? Those distributions, these are discrete distributions. But when the values for it, right? When the sample size gets large, right? When n is large. So when the value is large, what has happened now is that we have to approximate to a normal. So we're trying to convert it from something discrete to something continuous, right? I think you would have done this. Yeah, we would have done this for binomial to normal. Now we're doing it for the Poisson. When the Poisson too big, you could approximate it to a normal. Okay, I'll give you the exact conditions just now. But right, so you will need to remember these little things, right? Anybody remember what you do when you go from a discrete to a continuous distribution? There's something that we have to do. Anybody remember? Approximate now. Something else we have to do. It's kind of approximation, but there's a term for it. Standardized now. Standardizing is when you go into the normal 0, 1. Anybody remember? Beginning with C. All right, nice, Gail. Good job, Gail. Right, is continuity correction. Right, so it's continuity correction from one to the next. Okay, so I just want to do a couple examples like that, and then we will go into the past papers, right? All right, make sure you have your normal table because you'll need it now, right? So let's say we had to apply continuity correction here. Suppose I ask for a probability of 5 is less than or equal to x is less than or equal to 8. What I want you to remember is that this probability, this values of x are for 5, 6, 7, 8. So we have all those values, 6, 7, 8. But these values are discrete values. So what we need now is to include all the possible values if it were continuous. So it means we had to include like 4.8. 4.8 would approximate to 5. 8.4 that approximate to 8. So we have to cater for all these values. So when you apply continuity correction, you have to cater for all the values that will still give you 5 and 8 or 6 and 7. So the continuity correction means we have to change the range from 5 to 8 to 4.5 to 8.5. All right, so you have to remember that. So you need to basically cater for all these values, all the possibilities of these values if they were discrete. Okay, so that is a continuous there. Right, let's do one more, and then I'll give you some values to go check the answer for the table. Suppose it was 5 is less than x is less than or equal to 8. What would the continuity correction be? Wouldn't it be more than or equal to 4 point? Yeah, more than or equal to 4 point. Because it's integration, you already technically it doesn't matter if it's 4.5 or just more than 4.5. Try the one underneath and let's see. Natisha. I'm just logging in with a mother phone, boy. What would this one be? Guys, that looking good. Right here. So because 5 not included and you have 6, 7, 8, it will be the probability of 5.5 all the way until 8.5. Okay? So that's the way you work out continued correction. All right. So let's do one more. What's the probability of x is less than 4, less than 5? What will that be? What will the continued correction here be? A Grant? What will this here be? Probability of x is what? A Granty. One, two, two. Grant. Hey, Grant, you there? Nice job, Grant. So that would be less than 5 means you want values less than 5. So that would be like 4 and 3 and 2 and right? So 5 not included. So therefore, if 5 not included, it will be x is less than 4.5, correct? You don't want to include 4.5, right? Right, because 5 not included. Oh yeah, I forgot to give it equal to. Suppose it was equal to 5. What would be the continued correction for equal to 5? Nishta, what you'll get here? Nishta, you there? Right, more than 4.5, less than 5.5. Nice, Nishta. Good job. So it's between 4.5 and 5.5. Killing, how we paying attention, Killing? Now, where do we go from here now? We need to be able now to find the problem. So I wanted to use a table now, and let's see if we could find this probability here. Isn't it more than, oh gosh, yes, what I just said earlier. Right, remember this is integration. So if you're integrating between, right, if you're integrating between 4.5 and 5.5, it's the same as integrating to 4.5 is less than or equal to. Same thing. They both give you the same value. All right. So I want to give you something here, right? Let's assume that it wasn't a normal distribution. Well, whatever it was, it don't matter what it was, right? Right? Probability of, I asked for the probability of x is less than 120. I wanted to apply continued correction here, right? And tell me what the probability will be. And I want you to use the normal distribution. A normal x follows a normal distribution of 140 to 91. I want you to do everything. I want you to standardize it and then work it out. Try that fast. So apply continuity correction, then standardize whatever you get there and work it out. So when you apply the continuity correction, it will be probability of X is less than 119.5, right? Right? It'll be the probability of X is less than that. Now we need to standardize. So that'll be the probability of Z is less than 119.5 minus 140 all over the square root of 91. That's when you standardize it. How much is that? Minus 2.149. Right? So you remember when it's minus, it'll be 1 minus 5 of 2.149. So go to your table, tell me what you get, and then minus it from 1. Go to your table, find fine of 2.149. Right from the table, what you all got? Pi of 2.149. Anybody have an answer? Oh, yes, Senate 0.9842. 0.9842. And when you minus that, you should get the final answer 0.0158. All right, so that is a quick refresher on what you should know about the normal. All we're gonna do now is I'm gonna give you the conditions for Poisson to be a normal. Alright, quick little thing. Okay, write this down. If X follows a Poisson distribution with parameter lambda, and lambda is large, right? And lambda is large, the normal distribution can be used as an approximation. The normal distribution can be used as an approximation, right? Where X follows a normal of mean lambda and variance lambda, right? So remember, you go in from discrete to continuous. So you have to apply continuity correction. Right, those are some of the conditions that we need to know, right? Right, so let's try a quick example. Right, so let's say I give you a radioactive disintegration, gives counts that follow a Poisson. So it gives counts that follow a Poisson of mean 25 Becquerel. Right, so you have a radioactive disintegration, gives counts that follows a Poisson with a mean count of 25 Becquerel. I would like you to find the probability that in a 1 second interval, the count is between 23 and 27 inclusive. Right, so basically asking it, I want the probability between 23 to 23 baby mother. 23 is less than X, is less than 27. So I want you to find this one up, please. Try that fast. Apply the correction and then do your continuity. Sorry, do your continuity, then standardize and work it out. Work it out, then message your answer. right? And then you want to standardize it. So that'll be 22.5 minus, the mean is 15, and the standard deviation is square root of 15. Was it 50? Oh, sorry, 25. Sorry about that. I don't know where I get 50, most probably the last example. So it's 25, because remember it's a normal, 25, 25, right? All over 5 is less than or equal to x. 27.5 minus 25 over 5. So that'll give you the probability between what? 2.5 over 5. So that'll be minus 0.5 to positive 0.5. Right? How much y'all got there? Go to your table, and if you rearrange it, you should get 2 phi of 0.5 minus 1. How much is that? Zero 0.383. All right, nice. So that's basically what you need to know for continuous random variables and discrete random variables. Okay? The last thing left in this module is goodness of fit. Just like how in module 1 we did a chi-squared for test of independence, we need to learn to do a chi-squared for goodness of fit. So I'll give you some data, and we have to check and see if that data follows a particular distribution. So you have to remember all the distribution, uniform, binomial, and so on. All right, so those are the things that we need to learn, right? Let me see, before I give you a chi-squared, I want to run back through all the steps of the chi-squared. All right, let's do one more. Let's do a past paper with this. All right, let's go back and do one with a normal. What year was that, boy? Yeah, boy. Yeah, boy. Yeah, boy. Cause I do song like the Baran, and the Baran do song like me. I ever thought the Baran, don't be. The Baran do song like me. I will touch it, bum, 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 bum. Okay, let's go. Let's try 2017. Because I do song like the Baran, Modi Mama, do song like me. How you get to 5? That's a rule when the vowels are the same. When it's minus A is less than X is less than A. If you don't want to use that, you can do it the long way. Alright? Let's try this one here. Cause I do song like the Baran, or the Baran, do song like me. Alright, so let's try this one here, right? Right, let's see what you got. Only have two answers. Any more? All right, so first thing first, we recognize that this mean value is more than 15. So X will have to follow a normal distribution with mean 15 and variance 15. They want you now to find the probability that in 1 hour less than 32 calls, right? Less than 32 calls push-ups. Yeah, thanks. Sorry about that. I write 15, my mistake. Right? Remember, less than 32 calls. So remember, we have to apply continued correction, 32 not included. So that'll be X is less than 31.5. Then we have to standardize it. X. Oh, why this thing keep coming up like that? Right, probability, you have to standardize, right? So we standardize it now. Probability of Z is less than 31.5 minus 35 all over the square root of 35. And that will give you the probability of Z is less than what? Minus how much? Minus 0.592. So because it's less than minus, it will be 1 minus 5 of 0.592. There's a way to get the normal distribution and thing off your calculator. I'm just not too sure. I remember you go to menu, then you go to distribution, and you go to the normal, I think it's normal PD. And you can put in the values. Yeah, I think you put it in. What you all got? For 1 minus 5 of that value. .2769. Okay, now I got something different from the I got 0.056. I wonder if I picked the wrong one. Right, but you should be able to get this from a calculator. Can't remember what PD and CD mean. Huh? Let's try C. No, I don't know what it's C. Yeah, I can't remember now. I think it's PD and thing. Right, but you could get most of your values from the calculator. That's the Casio, of course. Huh? If you have a sharper, no bother with that. Bother with it. No bother with it. Right, and you have one more part to do. Find the probability between 31 and 39. Right, I give you all enough time already to finish it, right? So let's finish up that. Don't worry about that. So it's the probability of X between 31 and 39. Apply continuity correction. Calculate the probability that in 1 hour between 31 and 39. So we had to be, it'll be inclusive, right? So that would be 30.5, 39.5, right? Standardize, tell me what you get, and then work it out. .761. Right? Then you could use the rule like the last one and tell me what you get for the probability. 0.5534. Nice. So that's the way to do questions like this. Next thing we have to do is chi-squared, right? Hope all of you remember chi-squared. Copy down that fast. Let me see if I could find a chi-squared just to give you a little reminder. Otherwise, you'll have to read it up for homework, right? Right, we have chi-squared, goodness of fit to do, and finish up this module. All right, let's take a look at, let's see if I have any chi-squares. Hold on. Nope. There are the chi-squared here. All right. But anyway, for those who've seen it for the first time, there's nobody should be able to say it's already, man. All right. So remember, you have chi-squared. You always have to do a little test, right? When you do a chi-squared test, right, you have to be able to get a value from the table, and then you have to do a value from the standardized tables, right? And then you have to get one using the test statistic, which is the summation of observed minus expected all squared all over expected. You have to work out these two values and then compare them. Right? You have to compare them, and based on what you get, you'll be able to determine if it's a goodness of it. The problem now, if you all remember, right? You all remember that we used to have a table, and then we have observed values and all those things, right? The problem now is that we're going to have to work out, right? We're going to have to work out the probability of each one, and then use that probability to help us find the expected value. So we have to work out the probability based on the distribution, right? Because this chi-squared, what is chi-squared really doing? We check in to see if a set of values, I'm just making up something, right? We just check in to see if a set of values follow a particular distribution. So let's say it follows a normal distribution. We have to say, okay, it following a normal. All right, well, let's find the probability when x is 1, when x is 2, and work out the expected value, plug it back into this, and then compare it to the table value. Right, so that's kind of what we do it. So it's a little longer than the chi-squared from unit 1 because you have some probabilities to work out. Okay. And you will need that to be, of course, find the expected value. All right, I won't rush into that today, right? Next day, we focus on chi-squared, right? And we'll do a couple of the distributions. At least do a normal.